All right, so we're going to start talking about how do we determine if a function is increasing or decreasing without looking at the graph. So if we first look at the definition of increasing and decreasing functions, an increasing function typically is one that goes up. So as our x values get bigger, so I'm given a first x value and a second x value, and the second one's bigger than the first one. So as my x values get bigger, remember, f of x is the same thing as y, so my y values also get bigger. So I'm moving in a positive or an upward direction. I have a positive slope. On the contrary, if I have a decreasing function, so now if I have two x values, as my x values get bigger, my y values are getting smaller. So if my second x value is still bigger than my first x value, now my second y value is less than my first y value. So I'm going down, or I have a negative slope. So we're going to learn some tests for checking to see if a function is increasing or decreasing. Since increasing functions have a positive slope, if after I find my derivative, if my derivative is positive or greater than 0, then my function is increasing. Since decreasing functions have a negative slope, if after I find my derivative, if my derivative is less than 0 or negative, I can say my function is decreasing. And if my function equals 0, or excuse me, if my derivative equals 0, then I can say that my function is constant, which we've looked at before, that constant functions have a derivative of 0. So here's going to be kind of the guidelines to determine if it's increasing or decreasing. I'll find all my critical numbers. I'm going to use my critical numbers to set up intervals. Then I'm going to pick a test point in each interval and determine if my derivative is positive or negative in that interval. If my derivative is positive in that interval, I can conclude that in that interval I'm increasing. If my derivative is negative in that interval, then I can conclude that my function is decreasing. The reason we have to find the critical numbers first and use those to set up intervals is if you remember that theorem 3.2 from your book, the relative extrema theorem, tells us that if a function has a relative minimum or relative maximum, so some kind of a turn or hill or valley, sometimes it's referred to as well, there will be a critical number there. So if I have a hill or a valley, if I have a minimum or a maximum, notice at that point, at that minimum or at that maximum, if my function is going to change from increasing to decreasing or from decreasing to increasing, it will happen at that point. And we'll look a little bit more closely at that in class, kind of the why. But that's kind of where step one is coming from. Sometimes I get questions on that. So let's look at a couple examples. I think I have two. The first example, I want to find the open intervals where this function given here is increasing or is decreasing. So in order to determine where it's increasing or decreasing, I'm going to have to find critical numbers. To find critical numbers, I'm going to need a derivative. So before I find my derivative, I'm going to say that my function is the same thing as x cubed minus 3 over 2 x to the negative 2. I'm going to rewrite it as a polynomial, so I can just use my power rule as opposed to having to use my product rule. So then my derivative is going to be equal to 3x squared. The minus 2 comes down, giving me plus. The 2 will cancel, so when this minus 2 comes down, it becomes plus, and my 2's cancel out, leaving me with 3x. Minus 2 minus 1 is minus 3. And I'm going to go ahead and say then, setting my derivative equal to 0, I get 0 equals 3x squared plus 3 over x cubed. I would like to get a common denominator, because if I get a common denominator, I can go ahead and just set my derivative, or excuse me, my numerator equal to 0, because if a fraction is 0, that means the numerator must be 0. So I'm going to multiply top and bottom here of my first term by x cubed, and I get 0 equals 3x to the 5th plus 3 all over x cubed. So if I set my numerator equal to 0, that will tell me where my fraction is equal to 0. So I'm going to subtract 3 and divide by 3 at the same time, and I get x to the 5th equals negative 1. So if I take the 5th root of both sides, the 5th root of negative 1, the only number that times itself 5 times gives me negative 1 is negative 1. So I get critical numbers at x equals negative 1, or since 0 would make my derivative undefined, and I'm looking for critical numbers to be at places where my derivative is 0 or undefined, I'm also going to say negative 1 or 0. So I'm going to go ahead and set myself up some intervals. So I'm not, so any open intervals, so where is it increasing and decreasing? So I'm going to say I'm going to have an interval, I'm going to go ahead and switch colors for this. I'll have an interval from negative infinity up to -1. What's happening with my function on that interval? And then at -1, something may be happening because I have a critical number there, so I may change from increasing to decreasing. So I'm also going to check then the interval from -1 to 0. And then same thing, something might be happening at 0, so then from 0 to infinity. So I have 3 intervals to check. So I did step 1, I did step 2. Now I'm going to pick a test point in each interval. So I'm going to do my test point. So let's say between negative infinity and -1, let's say I pick -2. From -1 to 0, let's say I pick -1/2. And from 0 to infinity, let's say I pick 1. And then I have to determine what's my sign of f prime at my test point. So when I plug -2 into my derivative, so I'm going to plug -2 in here, and all I care about is my sign. I don't really care about what the actual value is. So 3 times -2 to the 5th, that's going to be a large negative number, plus 3 will still be negative. When I plug negative, so I'm going to have negative on top. When I plug -2 into the cube function, it's still negative. So negative divided by negative, I get a positive in my first interval. When I plug -1/2 in, I'm going to get a very, very small number since -1/2 to the 5th power. I know that's going to be 1 over -32, so -3 30-seconds plus 3 is going to be positive on top. When I plug a negative into my cube function, it's negative on the bottom, so positive over negative is negative. Please remember, you can use the aid of a calculator to determine this. I could just punch into my calculator -1/2 in for x and see what that gives me. Then I plug 1 in, and I'm going to get 1 to the 5th is 1, so I'm going to get 3 plus 3 is 6, so I'm going to get positive over positive, so I'm going to be positive here. So in conclusion, I'm going to go ahead and say that my function, so f of x, is decreasing on the interval from -1 to 0. I am going to do an open interval because I'm not 100% sure what's happening at negative. Well, I am. I guess -1 was my critical number. So at -1, my derivative was 0. So I want to make sure I use an interval. So f of x is decreasing from -1 to 0 and is increasing from negative infinity up to -1 and from 0 up to infinity. And there is my final answer. Looking at one more example. So I'm going to go through the same steps. So I have to find my critical numbers to begin with. So in order to find my critical numbers, I better find my derivative. Unfortunately, I'm going to have to use my chain rule here. So I'm going to let u be my inside function, x squared minus 4, v be u to the 2/3. U prime is then 2x, and v prime is then u to the -1/3. So I can say f prime of x is u prime times v prime, so I'm going to have 2x times, u can move to the bottom and I can make 1/3 positive, so I'll have x squared minus 4 to the positive 1/3. Remember, that means the cube root. So now I'm going to set my derivative equal to 0, and I'm going to find the values where my derivative is 0 and where my derivative is undefined. Well, in order for a fraction to be equal to 0, remember that just means the numerator needs to be 0. I can do that in my head, so I can see that if x were 0, it would make my numerator 0. So I will have a critical number at x equals 0. And then I'm going to ask myself, what values would make my denominator 0 and therefore my derivative undefined? Well, if x was 2, my denominator would be undefined, and if x was -2. So I'm going to go ahead and set up some intervals. I'm going to have more intervals this time. Change colors again. So I'm going to go from starting at negative infinity up to -2. That's the first critical number I hit, and then going from -2 up to 0. And I'm going to have to move my screen over. And then I'll go from 0 up to 2 and from 2 up to infinity. After I have my interval, I'll go ahead and pick a test point from each interval. So from negative infinity up to -2, maybe I pick -3. From -2 up to 0, -1. From 0 up to 2, 1. And from 2 up to infinity, 3. After I pick my test point, I'm going to plug it into my derivative and figure out what is the sign of my derivative at my test point. So when I plug negative 3 into my derivative, all right, I'm going to kind of bounce back and forth a little bit. Plugging negative 3 in, I see that's going to give me a negative on top. And on the bottom, negative 3 squared, so is going to be 9 minus 4 is going to be positive. So a negative over a positive, so my overall sign here is negative. When I plug negative 1 in, I get a negative on top, and on the bottom, I'm going to have 1 minus 4, which will be a negative. Cube root of a negative is still negative, so I'll have negative over negative, which is positive. When I plug 1 in, I get a positive on top, and on the bottom, I get 1 minus 4 is a negative, so a cube root of a negative is still negative, so positive over negative is negative. And then the last one I'm going to plug in is 3. So when I plug 3 in, I get a positive on top, and I get a positive on the bottom, so my overall function is positive. So now I'm going to go ahead and make my conclusion. And for my conclusion, I'm going to go, well, first of all, I'll determine if it's increasing or decreasing. So it's decreasing here, increasing here, decreasing, increasing. So for my conclusion, I can say that my function f of x is decreasing on the interval from negative infinity to negative 2 and from 0 to 2. And my function is increasing from negative 2 to 0 and from 2 to 0. And that is my conclusion. And that's it for increasing and decreasing functions.